Okay, so now we want to look at a dynamic game that's based on the Bertrand model with multi-characteristic differentiation. But what we'll see here now is we get an opposite conclusion as we did from the Cournot game, the Stackelberg model. So this is perhaps not an uncommon situation, right, in the real world where a dominant firm is a price leader. And so the dominant firm is going to set the price ahead of its competitors. And then firm 2 will set the price in period 2. So demand and costs are linear. So Q1 is just equal to alpha minus P1 plus P2. Q2 is just equal to alpha minus P2 plus P1. And then profit functions are just price times quantity. So note here, we're substituting in for quantity because price is our choice variable. So we have P times Q minus C times Q. Or just P minus C, Pi minus C times Q, which is alpha minus Pi plus Pj. So we need to use backwards induction again. So we're going to solve the period 2 problem for firm 2 first, right? And so we maximize firm 2's profit function given P1. So we just treat P1 as a constant. And we get alpha minus 2P2 plus P1 plus C equals 0. And then we solve that for P2. And so P2's best response, given any price for P1, is going to be alpha plus C over 2 plus 1/2 P1. Or we could just put everything over 2 and say alpha plus C plus P1 over 2. And then firm 1 says, okay, I'm going to take that best response function from firm 2, I'm going to plug it into my own profit maximization problem. And here now is my profit maximization, right, where we just plug in alpha plus C plus P1 over 2 for P2, and then we have P1 minus C here. And then we take the first order conditions, and we get 3 alpha plus 2C over 2 minus P1 equals 0. So let's look now at the prices and quantities and profits for the two firms. So in this case, we do get, not surprisingly perhaps, that firm 1's price is higher than firm 2. So 3 alpha plus 2C over 2, whereas firm 2's price is 5 alpha plus 4C over 4. But because of that higher price, they're actually going to sell less, right? Remember, they were symmetrical demand functions. And so quantity 1 is just 3 alpha over 4, and quantity 2 is 5 alpha over 4. And because of that, the higher price is not, in this case, enough to compensate for the lower quantity, and profits for firm 1 are 9 alpha squared over 8, which is less than profits for firm 2, which is 25 alpha squared over 16. And so unlike in the Stackelberg model, where they were competing on quantity, the follower or second firm earns a higher profit in this game. And so in this game, there's a second mover advantage where the price leader earns lower profits. Now, we just said, often there's a dominant firm that sets price first. And so how can we have that? Why would it be in their interest to do that? Well, sometimes they can still earn a higher profit if they have lower costs or they produce a better product, right? So they're a higher quality product than the competitor. And that may often be the case in a real world example. So now let's turn to thinking about, all right, well, if firms are looking at this from the beginning of period 1, whether they're Cournot or Bertrand, and we'll do a Cournot Stackelberg type game first and then a Bertrand type game second, do they want to be in this 2-period model, or would they prefer to be in a 1-period model? That is, do they want to set output or price in the first period, or do they want to wait until the second period? And so when we look at the Cournot model, it's probably not that surprising, right? That we end up, the subgame perfect Nash equilibrium, if they can choose whether to set quantity early or late, is that they always want to set it early. And so if we think about it, let's say firm I moves first, right? And so they can move either early or late. And then firm J moves, and they can move either early or late. Well, for firm J, in this case, it's always better to move early. Early is better whether firm 1 moves early, in which case they just get the standard Cournot profits, or if if firm I moves late, then firm J will get the higher profits in the Stackelberg model. And so knowing this, firm I is like, well, I don't want to be the follower in the Stackelberg model because I know I get lower profits there, so I'm just going to set it early. And so I think this is useful because it shows that if we think about the Cournot versus Stackelberg model, it may be in firms' best interests, if possible, to commit to an output level at the same time and then just have the standard static Cournot equilibrium rather than the Stackelberg equilibrium. Now, if we turn to the Bertrand model, right? So if Bertrand, now we're choosing price either in the early period or the later period. Now there's no dominant strategy for firm J who moves second. So if firm I moves early, firm J wants to move late because then they'll have the second mover advantage. And if firm I moves late, then firm J wants to move early because otherwise they're setting price at the same time and they're not going to get much profit. And so the firm I, seeing this, is now comparing, all right, 9 alpha squared over 8 if they're the early then late. And so they're like, no, I want to be the second mover advantage. So in this case, firm J might set the price first and then in the early period, and then firm I would set the price in the later period. And so it's possible that the firm that is sort of setting the price earlier actually does not have the competitive advantage as we've discussed.